Okay, welcome back to Unit 4. This is Lesson 3. For Lesson 3, we're going to be doing something a little bit different from Lesson 2, where we're completing the square. Now we're going to go back to factored form, really, because we're going to be learning something called the quadratic formula. So the quadratic formula is something that can be used when we are dealing with standard form that is unfactorable. So if I look at this equation that's given to me right here, this x squared minus 6x plus 7, I can try to use my sum and product rule to make a product of 7 and a sum of negative 6, but there are no two numbers that work. So before we would write that this is unfactorable and that there are no zeros, but that's simply not true. So what we've done in math is that we've come up with a formula to be able to solve for these problems. This is the formula, the quadratic formula. Now, when we're using the quadratic formula, what I like to do is I like to edit it a bit because I find that a lot of students have issues with this negative sign that's in front of the b. So I'm going to write negative 1 and then I'm going to put the b in brackets so that we always remember to replace our b with whatever value it is, because sometimes it's a negative, and then multiply it by negative 1. Usually students have a sign error here. So that's how we're going to fix that. If we write that negative 1 multiplied by b, there's really no way to have a sign error. Now, what you see next is that we have this weird plus or minus, and that's going to be because there are two, or possibility of two x-intercepts. So we're going to split up the equation in the end to where we add and where we subtract the next part. So this next part is that we're going to be square rooting and then in brackets b squared minus 4ac over 2a. And you're probably asking yourself right now, what are all these b's, c's, and a's? Well, they come from standard form. So if we go back and look at standard form, a is the value that comes in front of my x squared, which always goes first. B is obviously the second value, and it comes in front of my x, and c is my constant, the number at the end, even if that's a 0. Remember that the equation has to be written in this order from highest degree to lowest, and that it has to be equal to 0. There can't be any number on the other side. That's how we're going to be able to use the quadratic formula. So let's see an example of that, something really simple, where we're given the quadratic formula in standard form, which is my A, B, C, and it's already written in the proper order. So all I really need to do is write down my quadratic formula and then plug in the variables to solve. So I've written in my quadratic formula, and now I'm going to replace the variables. So I'm going to keep that negative 1. B, see now here's why I wrote that negative 1, because B is negative 11. So I'm going to write negative 11 plus or minus the square root of negative 11 squared minus 4 times A, which is 3, times C, which is negative 14, divided by 2 times A, which is 3. Now the next part, what I like to do is to solve for the exponents or anything inside of my brackets, which really that square root sign is a bracket. That's kind of what I tried to show you above here, because this square root sign is grouping the b squared minus 4ac together. So really I like to solve for that. It's called the discriminant, and it's going to be important to us. So I'm going to teach you this method of solving for the discriminant first, then separating, because it's going to play a role in our next lesson. So really what I want us to do on our calculator right now is to punch this in, just the part underneath the square root, and write down what it equals. So now I'm going to write my square root sign, and I can solve for the base 2, or the denominator, 2 times 3. I'll write that in, that's 6. So right now, negative 11 in brackets, make sure that that's in brackets, squared, minus 4 times 3 times negative 14. Press equal on your calculator, and you should get 289. Now, this number, this 289, is going to tell us the types of roots that we're going to have in the next lesson. So that's why it's important that I solve for that first. Then, now that I've solved for that, I can separate my equation into the plus and minus signs of that version. So now I'm going to separate the equation into my two x-intercepts. And really, I can solve for this part right now too, right? So negative 1 times negative 11 is 11. So x is equal to 11 plus the square root of 289 divided by 6. And then x is equal to 11 minus the square root of 289 divided by 6. So now you can see where that plus and minus sign comes in. What it's doing is that we're separating the equation really into these two different x-intercepts right now. So now I'll use my calculator and I'll type this in all in one shot. When I type that into my calculator in one shot, I need to remember that when I'm dealing with fractions, sometimes my calculator doesn't know to group, so I'm going to use brackets. That way I'm telling my calculator to put the first part, the numerator, together. Do that math first. So do 11 plus the square root of 289, then press equal, but I don't actually need to press equal unless I have a one-line calculator, then divide it by 6. So that's what the brackets are telling my calculator to do. So once I do that, I can solve for my both my x-intercepts and see that one of them, when I add, it's at 4.6, and when I subtract, it'll be at negative 1. This decimal right here is the reason why before we would say that it's not factorable. Because when we were factoring, all we could do is look at our multiplication table and do whole numbers. So now we can have this quadratic equation to basically find x-intercepts that have decimal places. Now I want to look at another example that maybe is a little bit trickier because it involves some extra steps. So if I look at this equation right now that's given to me, 5x squared minus 8x equals negative 4, it's not written in standard form yet. In other words, this constant is not in the right spot. It needs to be moved over, and then I need to set it equal to 0. So when I rewrite the equation, when I move that negative 4 over, it becomes a positive 4. Now it's equal to 0. Now I have my a, b, c in standard form, and I can use my quadratic equation. So I've written down my quadratic equation, and now I'll begin replacing my variables with b, which is a negative 8, plus or minus that negative 8 squared minus 4 times a, which is 5, times c, which is 4, divided by 2 multiplied by a, which is 5. Now I'll solve for the part under the discriminant. And actually, you know what? I can solve for this part too. I can do that all together here. So negative 1 times 8 is 8 plus or minus the square root of 2 times 5, which is 10. And now I'll use my calculator, bracket negative 8 squared minus 4 times 5 times 4. And that ends up being negative 16. Now, stop, because I want to do the next part of separating them, but really that's why I do the discriminant first, or do this step of solving for all the parts separately, because can I square root a negative number? I can't. There's no way. My calculator is going to say error. So when I try to square root a negative 25, like for example, because we're used to square rooting 25, it's 5. But there's no way of square rooting a negative 25 because I can't have negative 5 times negative 5 equal a negative 25. A negative and a negative will always be a positive. So there's just no way to produce negative numbers when you square. So what does that mean? Well, it means what you think. You weren't able to factor it. You weren't able to use the quadratic equation. So that really means there are no x-intercepts. Well, what does that mean, there are no x-intercepts? Well, that simply means, I'll draw an image here so you can see, that maybe you have a quadratic like this. That's above the x-axis, the vertex is above the x-axis, and it's pointed upwards. So it'll never cross x. Or maybe you have something like this, where the vertex is below the x-axis and it's pointed down. It'll never cross the x-intercepts, or the x-axis, to form x-intercepts. So now we're going to learn something in our next lesson about the discriminant, about that negative, about whether it has a positive or negative number, and what that means for the types of roots that we can have. Now for this next page, what I want to do is I want to go through rearranging these three equations with you, and then ultimately have you practice using the quadratic formula. So right now for the first one, it's very similar to the last example that we did, where we have this 6 on the wrong side and we have to bring it over. So when we bring that 6 over, we're going to have x squared minus x minus 6. Now just be careful here with your a, b, and c. A is positive 1, b is negative 1, and c is negative 6. And then you're going to use your quadratic equation to solve. Now if you look at this next part over here, you're probably saying to yourself, well, how, it's got brackets, what am I going to do? Well, we know that we can't deal with brackets, so we have to break them. And we can use this method of FOIL. 2 times x is 2x squared. 2x minus 8 is negative 16x. 1 times x is 1x. 1 times negative 8 is negative 8. Group the like terms together. Negative 16 and positive 1 is negative 15. X minus 8. Now I have my A, B, and C, and I can go forward from there. Then this next part here, it's the same idea, but now it's in a format that we're maybe not used to, right? Like this was factored form that then we had to expand. This was already in standard form. And now what format is this in that we did in our previous 2 lessons? That's right. This is vertex form. So we're used to expanding vertex form from our first unit that we talked about in lesson 1 of Unit 4. We did a review of it. And we used a short form in Unit 1, but we didn't really like that, so I told you just to expand it the old way using FOIL from grade 9. So here we go. We can use that method of just writing the bracket down twice because I have that square. Then I can expand it. X times x, x squared, x times negative 1 is negative 1x, negative 1 times x is negative 1x, negative 1 times negative 1 is positive 1. I can then collect any like terms. Then I can expand the 2 inside my bracket to break it. Collect my constants at the end. And now I have my A, B, C that I can use my quadratic equation for. So now that's exactly what we're going to do now for all 3 of these. We're going to use that quadratic equation, which is that x equals negative 1 times b plus or minus the square root of b squared minus 4ac over 2a. You're going to use that 3 times to practice, and then you're going to check your solutions on the filled-in version of this note, which is posted on Google Classroom. Also, for example number 3, I want you to basically use the quadratic equation again. and find that x value that or the x-intercepts that we're used to of when the ball hits the ground. There's really nothing new to this word problem. It's basically find the x-intercepts, but now we can't find the x-intercepts using factoring. We're going to find the x-intercepts using this quadratic equation. For example number 4, we're not going to go there. We're not going to do it. We're going to leave it blank just because of the issues that we're having with the pandemic and what I really need to cover with you, which is the overall expectations.